Have you ever tried to fold a piece of paper more than 7 times? Go ahead, try it. It feels physically impossible. But in 2002, a high school student named Brittany Gallivan folded a single piece of toilet paper 12 times. She didn't break the laws of physics, she broke an assumption. The problem wasn't the material, it was the mental model. Our brain builds these models for everything, creating cognitive shortcuts that are incredibly useful until they become a cage. This cognitive cage has a name, the Einsteinlung effect. It's a German word for mindset. In the 1940s, psychologist Abraham Lutyens gave people a set of water jug problems. For the first several puzzles, a complex, multi-step solution worked every time. Their brains learned the pattern. Then he presented a new problem that could be solved with a much simpler one-step method. The vast majority missed it. Their brains, now experts in the complex method, literally could not see the shortcut. They were blinded by their own experience. This extends beyond methods to objects themselves. It's called functional fixedness. Look at a hammer. What is it for? Hitting nails, right? In a famous experiment, people were given a candle, a box of thumbtacks, and matches, and told to attach the candle to a wall. Most people tried to tack the candle directly to the wall, which failed. They saw the box only as a container for the tacks. The solution is to empty the box, tack the box to the wall, and place the candle inside. The box's function had to be redefined from container to shelf. Its hammerness had to be ignored. Why does this happen? Your brain is a stunningly efficient filing system. When you learn what a box is, neurons form connections. Every time you use a box as a container, that connection gets stronger. This is Hebbian theory. Neurons that fire together wire together. This creates superhighways for common thoughts. But when a problem requires you to use a box as a shelf, there's no road for that thought. You have to go off-road, building a new tiny neural pathway from scratch. That's slow, and it feels wrong. Here's where it gets strange. Your brain seems to treat abstract ideas like physical places. The part of your brain that helps you navigate your city, the hippocampus, is also involved in organizing memories and concepts. London taxi drivers, who memorize thousands of streets, have measurably larger hippocampi. Their mental map of the city is a real physical structure. When you face an impossible problem, you are, in a sense, lost. You're standing at a familiar intersection in your mind, but the place you need to go isn't on your current map. The solution feels impossible because, neurologically, it doesn't exist yet. So how do we draw the new map? The answer often comes when we stop trying. That aha moment, the sudden insight, has a neural signature. Brain scans show that just before a solution appears, there's a burst of high-frequency gamma wave activity in the anterior superior temporal gyrus, right above your ear. This often happens when the brain's focused analytical networks relax and the default mode network, your daydreaming brain, takes over. It starts making long-shot connections between distant mental concepts, like connecting box to shelf. It's the neurological equivalent of looking at the stars and seeing a new constellation. This is why the advice to think outside the box is literally what you need to do. Consider the 9-dot puzzle. Connect all 9 dots with 4 straight lines without lifting your pen. Most people fail because they create an imaginary box around the dots and try to stay within it. The solution requires you to extend the lines beyond the boundary of the dots. The constraint isn't in the rules, it's in your head. The impossible becomes possible the moment you question the invisible walls of the problem. The greatest breakthroughs in science often come from this kind of perspective shift. Johannes Kepler struggled for years to understand planetary orbits, assuming they were perfect circles because circles were heavenly. The solution came when he compared the orbit to an ellipse, a less perfect shape. He broke a deeply ingrained assumption. The structure of the atom was famously conceptualized by modeling it after the solar system. A huge, abstract problem was solved by borrowing a map from a completely different domain. This is intellectual cross-pollination. It's taking the shelf idea from your mental furniture department and applying it to your thumbtack problem. There's a famous story about Christopher Columbus, who, upon his return, was told by a nobleman that discovering the Americas was no great feat. In response, Columbus challenged the table to make an egg stand on its end. After everyone failed, Columbus took the egg, tapped it gently on the table to slightly crush its base, and it stood upright. The solution was trivial, but only after he broke the unspoken rule that the egg had to remain perfectly intact. The impossibility was an artifact of their assumptions. Once the solution is seen, it becomes permanently obvious. You can't unsee it. So, when a problem feels impossible, what are you actually feeling? You are feeling the boundaries of your current mental map. You are experiencing the immense energy required to build a new neural road in the wilderness. The feeling of impossible isn't a fact about the world. It's a signal about the state of your brain. It's an invitation to stop, to rest, to daydream, and to ask a better question. What invisible rule am I following? Because the solution isn't out there. It's waiting to be built, one new connection at a time, in here.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.